Good morning. Can you hear me? Can you hear me? Can you hear me? Can you hear me? Okay. Firstly, let's review. Okay. Firstly, yeah. Last week, I leave 2 assignments for you, and here I received 3 papers assignments. Jisoo, Banner, you just sent me the exercise 1, right? And Facer, the thing is, you just practice what I told you in class, not the practice you need to complete after class. Okay, firstly, let's look at Jisoo's assignments. Yeah. Here, first assignment, I ask you to calculate the quantities. Right? It include the data include 2, 5, 8, 10, 15, 20, 1, 2, 3, 4, 5, 6. Totally 6 data. Okay, and yeah, 2 students use different ways, different methods to do this. That's quite good. Here's Banner's. Okay, Banner calculate the Q1, Q2, Q3 step by step. Use the number of the data, and here is 6. And firstly, he decide the position of Q1, and then he calculate the Q1. Yeah, all of them are correct. Okay, this is the one way to calculate Q1, Q2, Q3. And let's look at Jisoo's. Jisoo used the SPSS software to help her to calculate the quartiles. Okay, that's quite good. And also you can see that she used the frequencies. Okay, so, and I think she input the data to the SPSS, and then she used the frequencies to calculate Q1, Q2, and Q3. right? Yeah. Here, I think I'd better to show you. Yeah. Firstly, new data. You want to establish a new data. Here is two, five, 8, 10. 2, 5, 8, 10, 15, 20. Okay, so establish a variable first. This variable, it can be X or Y. That's the name of the variable. That's okay. And also here the decimal can be, because so I use 0 and the measure use scale here. Okay. So establish a new variable first and then input the data. Analyze descriptive frequencies. Use frequencies, we can calculate the percentiles. X. Okay, and then statistics. Here we have the percentiles. Okay. Yeah. Or because here we just 25%, so we will use the quartiles, not this one, just the quartiles. Okay. Percentiles, you can input what you want the computer calculate. But this time we use the quartile enough. Continue. Okay, so you got the 25 percentile is 4.25. 50 percentiles is 9. And 75 percentiles is 16.25. Okay, so that's Giselle did. Great. Banner and Giselle, you all did it correct. Very good. Okay, assignment 2. Yes, please use the height and the weight this data file to complete. Firstly, use 2 different ways to assess if the variable height can be considered normal. Okay, firstly, I need to open the file. Okay, and yes, the variable height, you need to access if it is normal distribution. I think the second lecture, I demonstrate several ways to access if the variable is normal or disnormal, right? Everyone still remember? Okay, you can use the gram picture diagram. You can use the diagram, or you can use the statistic data. Yes, firstly, look, analyze here, descriptive, explore. Okay, input height. Okay, and then here, statistics. Yeah, that's okay. Plots. Yes, please choose the normality plots with tests. Here, and here is the histogram. then look here. You can use the skewness, kurtosis, yes, to help you to access. This time the skewness is minus 0.614. The kurtosis is 0.742. Yeah, it shows that the skewness and the kurtosis are close to 0. Okay, so in this time, we can say that height can be assessed to be normal. Okay. Second method, we will use the tests of normality. Here shows 2 test results. One is KS test, another is SW. Anyone can tell me which time we will use the result of KS, which time we will use the SW? Anybody can tell me? Yeah, because in different times we will use, sometimes we choose SW, okay? Sometimes we choose this result. So would you please tell me what's the difference between these 2 results? It depends on anyone can answer. Anyone know it? Okay, you can look at the handout of lecture 2. There, yeah, in lecture 2, I told you that the test of normality, which result will be chosen, it depends on the sample size. Okay, if the sample size is more than 100, which means the sample is a bigger sample, then we can use the KS result. If the sample size is less than SW, less than 100, then so that means it's a small size sample. So we'd better to select the result of SW, this one. Now, how many samples do we have for this case? How many? Okay, so how many samples do we have for this time? Anybody please tell me? No, Jisoo, that's not a sample. 1 is group. One is the number of group. So how many samples do we have in this case? Anybody knows? Okay, let's look at the data here. So here I think you have question about the sample size. Sample size means how many samples do we have? For example, height. Here, height is one group. Okay, and the sample size means what? Look here, we have totally 30 samples because we measure 30 students. Okay, understand? So in this case, right, Jisoo, right, you're right. Okay, so here we have 30. The sample size is sample number is 30. It's less than 100, so that means it's a small size. Okay, so we need to use this result. From here, we can say that the SW statistic is 0.958, and the corresponding significance is 0.269, which is less than 0.05. So we accept the hypothesis. It means the height can be considered as normal distribution. Okay? Yeah. Yes, yes, please paste the result, this result, and also you need to add some words to express the conclusion and why you draw this conclusion. Okay? Good. Okay. Also here is the histogram, right? And for if it's a normal distribution, then the shape of this histogram should similar to the line like this. And also through this diagram, you can say that the distribution of the height is close to normal. Okay, also here is another way to access the normal distribution. Here, look, all the samples, 1, 2, 3, all these 30 samples, they are very close to this line. Okay, since they are very close, the case for more or less in the straight line, they were more or less in the straight line. So I can say that they can be considered as normal distribution. Look, all of them very close to this line, right? Okay. Also here's another way to help you to judge if it's normal or disnormal. Here, this is the 0 line, right? And here is the difference from the 0. I told you that if this is a pure normal distribution, then all these samples will fall on the 0 line. So that means this is the difference between a normal distribution, right? And since all these samples, the distance between the 0 is less than, here is less than 0.5, here is less than 0.75, so that means this difference is small. Okay, so that means we can say that the height can be considered as normal. Also here is the box. It's a box plots. Okay, here we have 1, 2, 3. This 1, 2, 3, 4. These 4 samples means they are a little bit away from the normal. Okay, but not too much. Okay, also here the medium. Here is the median, right? The median is positioned in the close to the center of the box. It's not right on the center. If it's right on the center, then it should be here, right? But it's not right. It's close to the center of the box. This line it shows the median. The median is close to near to the center of the box. So that means the height can be considered as normal. Okay. Yeah. So you can use two way of them. Okay, you can choose different ways. So yes, the result is good. Okay, but the thing is you should analyze and then draw conclusion. Okay? Because you have no conclusion, right? You just show the results. Yeah. Here you show the boxy plot and the histogram. Okay. Also, here I would like to show you the histogram with the normal curve. Let's look at here. You click the graph, legacy diagram, and then, yeah, look here, it has a histogram. Okay, variable height. Okay. Yeah. Yeah. Yes, please select the display normal curve. Okay, display normal curve. And then, okay. So here is the normal curve. And this is this point, when you connect them, that's the curve of this case. This is the normal curve. Okay, and you can see that all of these shapes, it's close to this curve. Okay, so that means it can be considered as normal. Okay. Also, here you also can use other ways to display. For example, the PP plot. Yeah, look here, it's the PP plot. It's the same. We use Explore. If you don't use Explore, you also can use the PP plot. You can use the QQ plot. You can use the histogram. Yeah. Okay, understand? Here is the PP plot. Okay, if all the samples falls up and down in one line, that means it can be considered as normal. And here you can see that all the samples very close to this straight line. So that means it can be considered as normal. Yeah, if it's not a normal distribution, yeah, you can look here. You can change. For example, I type in several data, and it will change the distribution. Look, if I type in 4 data like this, and then you can see it's totally different. Look. Can you see it? Yeah, all of these samples not very close to the line here. Okay, it's totally different. Yeah, and also here you can see that it's more than 1 point. It's more than 1.0, the distance. Okay, so all of these samples, yeah, they are far away from the 0 line. So it's not the normal distribution. Okay, also like this, different. And also look here, look at this is totally different shape of the normal curve, right? The normal curve should like this. Okay, and here it falls like this. So it's totally different. Okay, and also look, here we have some data marked with the star, 4 stars. Okay, this it means all of these 3, 2, 3, 3, 3, 4, 3, 1, these 4 data is far away from the normal. Okay, yes. Also, let's look at the test of normality. Look. Yes, we have totally 34 samples, right? And the SW, the statistic is 0.642. The corresponding significance is less than 0.001. So that means yes, this variable height cannot be considered as normal distribution. Also, the skewness is minus 2.284. The kurtosis is 4.375. They are all not. They are all far away from 0, right? Because so from the skewness and the kurtosis, it also shows the height is not normal distribution. Okay, can you understand? Can you understand? Great. Okay, Next, let's look at this one here. Please analyze. If the mean height is equal to 160, here okay, and one student asked me the gender. Okay, yes, please, here the gender 3 it's wrong. Okay, so here you need to 1. So I think here it should be 1. Why? Because yes, according to the rule here, 5 2 5 1 5 2 5 1. Okay, so here when we type in, sometimes when we type in the data, yes, sometimes we make mistake. So you need to check. Okay, now I changed the data here, and also, yeah, I'd better to answer the question here. For example, the G size here, we have M, S, L, right? If you don't want to use S, L, M, X, L, you want to use 1, 2, 3, 4, 5, then you can use transform. And transform record into different variables. Here, G size, okay, and output, because this is the original variable, and here you need to input the new variable. So the name may also can be G size, okay, /1, okay, change, okay, and old and new, the value here is the axis. Do we have access here? Let me see. Yes, would you please check which is the smallest? If we have the S, L, M, L, X, L, okay, S, sorry, I can't. S, the new value is 1, M, new value is 2, add L, the new value is 3, and XL, the new value is 4, for example, like this. And okay. Okay, then, yeah, we can see that the G size 1, M is 2, S is 1, L is 3. Okay, so all of these S, M, L, X, L transform to 1, 2, 3, 4, 5. Yeah, and also here, you better to use the new value, okay? So if the gender here is male and female, for example, here is male or female, then you'd better to transform to 1 or 2. Okay, the same way. Okay, then next we will use the compare-means one sample t-test. Height. Okay, the compare-means one sample t-test. Yes, the height here, and the test value is 160. Then we have the result here. Yeah, Jisoo is right. Jisoo here is right, okay. But what's wrong is, look here. The value, the t-value is 0.203. Yes, it's correct. If the significance level is 0.05, then the probability p corresponding to the t-value is, yes, Jisoo, would you please tell me this p probability p, the value? Would you please tell me the value itself? Do you know now, Jisoo? Anybody know? Anybody know? The probability p corresponding to the t-value, or you can say that the corresponding significance of this test. No. Okay, so that means you didn't know which one is the significance, right? Look. Here is t, 0.203. It's correct. Okay, and the corresponding probability p, or sometimes we say that the corresponding significance is this data. Okay, so here is 0.841. So it's not the less than 0.001. The p corresponding to the t-value is 0.841. Okay, which is more than the significance level. So, the null hypotheses are accepted. So, the mean height of the adolescents has no significant difference with 160 centimeters. Look, there are 95% confidence that the mean height of these people is not this one. You should add 160. It's between Okay, so here is less than 160. Here is more than 160. So that means the mean can be considered has no difference because the 160 is included in this area, right? Because here is less than, here is more than, so it's included. So we say that the mean height can be considered equal to 160. Okay, understand? Okay, everyone, please let me know. Please tell me. Okay, the significance level is default. So, because that's why you need to practice. How about others? Banner. The significance level is 0.05. That's the default level. Okay. But it's not always, but it's default. Yes, Fraser, can you understand? Oh, Kamlu is not in. Where is Kamlu? Okay, let's continue. Okay, next is, yes, here is the one sample t-test. Okay, and then next, please analyze if the mean weight of male and female are equal. The mean weight, if the mean weight of male and female, here we have two groups. One group is male, another group is female, right? So all these samples are independent, right? Are independent. So, and also the weight, we considered the weight as normal distribution. So we can use the independent t-test. Analyze here, compare means, independent sample t-test here, okay, and then input weight. Yeah, the grouping variable here is the gender. Define groups. Gender here, 1 male, 2 female. So group 1 is 1, group 2 is 2. Continue. Okay. Yeah, here is the answer. Okay, here is the result of independent t-test. Yes, yeah, the GSO is alright. GSO, the result shows here is correct. Okay, so let's look at the GSOs. Okay, from here you can say independent samples t-test can be divided into 2 steps. First, the Levin's test. Yeah, that's this test from here to here. Okay, the Levin's test is performed for whether the 2 population variance is equal. Okay, and the result shows F value is this one. F value is 0.310. The probability P corresponding to the F value, this one, is 0.582, okay, which is more than significance level 0.05. So it can be concluded that the 2 population variance is equal, has no significant difference. Yes, this step is correct. Good. And then, after we test the variance, then next we test the equality of means, right? Okay, so here the t value, yes, because the variance is equal assumed, so we look at the results in this row, right? Okay, and here the t value is 2.891. Yeah, correct. And the two-tiered significance is 0.008. 0.008, right? Good. 0.008 is less than significance level 0.05. It's not more than, okay? Here is less than. Less than significance level 0.05. So it can be concluded that the means of 2 population has significant difference. So the conclusion is wrong. Okay. Also here you see the 90% confidence can say that the mean difference. The mean difference, here we say it's mean difference. The mean difference is from 2.32 to 13.75. It means they are all more than 0. So 0 is not included. So that means it has significant difference. Okay, so yeah. Okay, so did you find? Yes, right. Benna, it's right. It's correct. Okay, okay. Okay, so here, okay, great. Okay, now, here is through this practice, yes, we reviewed what we learned last week, right? Last lecture. This time, next, we will continue to the next lecture. Here, I will stop first and then open a new lecture, okay? So it's easier for you to review the video.